Point 3. But before we go to this exercise, I want to explain two things. We are going to find the roots of a quadratic equation. So in order to do that, you need to know two things. One is finding roots by completing the square method, and the other one is the other method is called by quadratic formulas. Finding the roots by applying quadratic formulas. Anyway, for this completing the squares, I will give you two examples. Let's take example of this one quadratic equation. Let me just write down 4x squared plus 3x plus 5 equals 0. What we need to do is we need to expand it in square, completing the square. A plus b whole square formula, we need to expand that. So what you have to do is you need to expand the two terms having variables x. In these two terms we have x as variables, so you have to expand this in such a way that it forms a formula of a plus b whole square formula, a plus b whole square formula, or a minus b whole square formula, depending on this sign. Here it is plus, so this should be expanded in such a way that it forms a plus b whole square formula. What is a plus b whole square formula? A squared plus twice ab plus b squared. So just by looking at 4, the square of 4 is 2, so 2x squared. This term can be written as 2x whole square. This will just give us this 4x squared. So a squared plus twice a, we took as 2x. Now b. First term we have written down, second term is this one. You have to write something that will give us 3x. 2 into 2 is 4. So what should give us 3x? It is already 4. So if we write like this, just check it, 4 into 3 by 4 will give us 3. 4 will get cancelled. So here it is 4, so we can write 3 by 4 twice ab. So now b is how much? 3 by 4. This one, 2 into 2 is 4. 4 and 4 will get cancelled, and we have 3x. So this one will give us 3x. A squared plus 2ab plus b squared. So which one is extra? We have written this one. This one has been written extra. So in order to cancel that, we have to just minus the same value. This minus this will give us 0. So we can write this down like this, plus what is left here, 5 equals to 0. So what do we get here? A squared plus 2ab plus b squared. Now what is a here? 2x. What is b? 3 by 4. So this whole term can be written down as a plus b is this one, b whole square minus 3 by 4 square plus 5 equals 0. And in this way we will solve the quadratic equation. This is not the complete answer. This is just the method how we are doing this. Another example I will give you is this: 3x squared minus 5x plus 2 equals 0. When you look here, this 3 does not have any square root. Like 4, we wrote down as 2 squared. So what do we do here? We have to multiply all these things by 3. Multiplying by 3. What do we get here if we multiply all these things by 3? 3 into 3 is 9x squared. 3 into 5 is 15x. 3 into 2 is 6 equals 3 into 0 is 0. We get this. So what we can do here is, why we are multiplying 3? So that we can get a square here. Now 9 can be written as 3x whole square. This is minus. So now this comes into play. A minus b whole square comes into play, because here there's a minus sign. So a square minus twice, I'm applying the formula of a minus b whole square. A square minus twice a is 3x b. You have to write a value of p so that this all things will give us 15. 3 into 2 is 6. So I can write there 15 by 6. Then 3 into 2 is 6. 6 will get cancelled and we have 15 here. So now next, a square minus 2ab plus b square. Okay guys, just look here. 6 and 15 can be cancelled or not. 6 into 3 into 2 is 6. 3 into 5, so we can write there 5 by 2, because 2 into 3 is 6, 2, right? So 2 and 6 will get cancelled. 2 into 1 is 2, 2 into 3, 3 into 5 is 15. So this one we will get 2 by 5, and this is extra, right? Now look here, this value is this expansion is this 2 into 3 by x into 5 by 2. Now we are writing this extra, this is extra, this one is, so we have to minus the same value, plus 6. When you solve this, you exactly get this one. So what do we get here? A square minus 2ab plus b square will give us a minus b whole square. This one is written. Now minus 5 by 2 x square, 5 by 2 square plus 6 equals 0. This is how we find the roots of a quadratic equation by completing the square method. Now the next method. Second method is by applying quadratic formula. Quadratic formula. Now the quadratic formula is, we have discriminant. In short, discriminant is denoted by capital letter T. The formula for discriminant is b square minus 4ac. According to this discriminant, we can find the roots. How do we find the roots? X, by applying this formula, b square plus minus square root of discriminant by twice a. Now, if the discriminant is greater than 0, then we have two distinct roots. If you get discriminant greater than 0, then you have two distinct roots. If you get t equals to 0, then you have one root. If discriminant is less than 0, that means negative, then there is no roots. Keep these things in mind. If discriminant is greater than 0, then you have two distinct roots. If discriminant you get equals to 0, then you have one root. If discriminant is less than 0, then it has no roots. And after finding the discriminant, you apply this formula to find the roots. b squared plus minus square root of t by twice a. Let me give you an example of this one. This formula. So for example, you have a quadratic equation. What should I write? Okay, 3x squared minus 5x plus 2 equals to 0. Now as you can see here, we have b, a, c. So a is the first value. What is the coefficient of a? 3. The coefficient of b will be here, minus 5. C is 2. Now let's find the discriminant d. b squared minus 4ac. b squared is minus 5 whole square. 4a is 3. 4ac, c is 2. 5 into 5 is 25. Minus 4 and 3 is 12. 12 and 3 is 24. You get here 1. So discriminant is greater than 0. So if the discriminant is greater than 0, how much we'll get? We'll get two distinct roots. So that's how we find out. Now we can apply the formula. X equals to b squared plus minus d by twice a. What is p square? P square will give us 25 plus minus d is how much? 1. 2a. 2 into 3. A is 3. So 2 into 3 is 6. So we get two roots, two distinct roots. One will be 25 plus square root of 1 by 6, and the other will be 25 minus 1 by 6. So these are the two distinct roots. That's how we apply the quadratic formula to find the roots of a quadratic equation. And you know the completing the square method also. It's a little bit complicated, but once you start doing the sums, then it becomes easier. So now let us solve the exercise 4.3. Let me solve the first exercise 4.3, question number 1, Roman number 1. Find the roots of the following quadratic equations if they exist by method of completing the square method. So here we will apply completing the square method. So as you can see here, the first term is 2x squared minus 7x. Here the two terms that has a constant, that has a variable has sign minus. So you have to apply a minus b whole square formula. So in order to make this a complete square, you have to multiply this by 2. So multiplying by 2, what do we get here? 2 into 2 is 4x squared, 7 into 2 is 14x, 3 into 2 is 6 equals 0. So now you can apply the formula completing the square. A squared 2x whole square, a squared minus 2a is 2ab. What should be b? What should be the value of b so that this whole value will give us this 14x? 2 into 2 is 4. So we can write here 7 by 2. 4 and 2 will get cancelled. 2 into 1, 2 into 2. 2 into 7 is 14. So we get here 7 by 2. P is 7 by 2. A square minus 2ab plus b square. B is, this is extra, so you have to cancel this. These two will get cancelled 0. Now what is left here? Plus 6. This is left. Okay, now let's apply the formula for this one. A minus b whole square. A minus b whole square. What is left? This one minus 7 into 7 is 49. 2 into 2 is 4 plus 6 equals 0. Now let's shift this to the right hand side. 2x minus 7 by 2 equals to, minus will become plus, plus will become minus. Let's do LCM. 49 minus 1 into 4 is 4 to 6 is 24. Okay, now 2x minus 7 by 2, 49 minus 24 is 25. Square will bring it here, it will become square. We're shifting it to the right hand side, it becomes square root. So what do we get here? Plus minus. Okay, when there is a square root, there should always be plus minus. So 2x minus 7 by 2 equals plus minus 5 by 2. 5 square, 2 square. It will cancel out the square roots and we get here plus minus 5 by 2. So 2x equals, I'm shifting this, 7 by 2 plus minus 5 by 2. So see, you can write this down like this: 7 plus minus 5, 4. If we shift this here, it will become 4 and plus minus 4. So we have two values of x. X equals to 7 plus 5 by 4, or x equals to 7 minus 5 by 4. So what do we get here? X equals to 12 by 4 equals to 3. X equals to 2 by 4 equals to 1 by 2. Therefore, the roots are 3 and 1 by 2. See, we found the roots by applying the method of completing the square. Let's do one more. Now I will do question number Roman number 2. Okay, wait, I'll do Roman number 3. 4x squared plus 4 into root 3x plus 3 equals 0. Now this 4 is already 4, we can write as 2 whole square. So this will become 2x squared, see plus, so plus twice a 2 into 2 is b should be root 3. 2 into 2 is 4, into root 3 is 4 root 3x. So this will exactly give us this value. So b is root 3. A square plus twice ab plus b square, completing the square method, minus root 3 square. This is extra, so this should be cancelled with by this, plus 3 equals 0. So for this we can write the formula: a square plus twice ab plus b square will a plus b whole square minus root 3 into root 3 will give us 3 plus 3 equals 0. These two will get cancelled. Now what we have here, 2x plus root 3 square equals to 0. Square root will come this side, the square will vanish, so we have 2x plus root 3 equals 0. Now shift this to the other side, 2x equals to minus root 3, x equals to minus root 3 by 2. See, here we got one distinct value, so that means discriminant is equal to 0. If you find the discriminant of this, you will get is 0. Let's just do it sidewise. What is a here? A is 4, b is 4 root 3, c is 3. Let's apply the formula: b square minus 4ac. b square will be this: 4 into 4 is 16, and 3 root 3 into root 3 is 3. This will give us minus 4 into a is 4 into c is 3. 16 into 3 into 6 is 18, and 3 into 1 is 3, 4, 48, minus 4 into 4 is 16 into 3 is, see, we got here 0. That's why we got the one distinct. So the roots are minus root 3 by 2, comma, minus root 3 by 2. So that's how we find out. Please do question number 2 and 4. Try to solve it, 2 and 4. So we'll continue in the next class. We'll do the next question, that is applying the quadratic formula. So that's it for today. Thank you guys.